There are certain objectives as usual, and let us start by the first objective. Before the first objective, we have two things in this section: exponential equations and logarithmic equations. We will talk today, inshallah, about exponential equations. Okay, there are two methods. We will learn two methods to solve exponential equations. First method in objective 1, second method in objective 2. So let us first define what we mean by exponential equation. We studied exponential function. We said that y equals to b to the power x is exponential function if b is greater than 0 and different than 1. But now what about exponential equation? Well, it is an equation. Equation means there is equality sign. Equality sign. Equation containing a variable in an exponent. So for example, 2 to the power 3x minus 8 equals 16. This is exponential equation because there is x in the power. 4 to the power x equals 15. 40e to the power 0.6x equals 240. All of these are exponential equations because x is in the power. Okay. The question, how to solve exponential equations? Any question about this objective would be solve. Solve means find the solutions. What are the numbers that make this equation correct? Yani if you replace x by what? Then the left-hand side would be equal to the right-hand side. And you can try, for example, 1. If you put x1 and use the calculator, then 3 minus 8, negative 5. Is 2 to the power negative 5 equals 16? No. So 1 is not a solution of this equation. So we need to find the solutions. Okay, there must be a method to find the solutions. So the first method, use like bases to solve exponential equations. Okay, by express each side as a power of the same base, have the same base or like bases. If you have the same base in both sides, then you have b to the power m equals to b to the power n, then you get m equals n. Okay, so you first these are the steps. First, you write it in this form. Okay, write both sides with the same base. Then you get m equals n, and then you solve and find the value of x. Example. This is the first example. Part A, solve. The question is solve. 2 to the power 3x minus 8 equals to 16. How to solve this question? Okay, what is the base in the left-hand side? The base is 2. What is the number in the right-hand side? 16. Now you ask yourself, can I write 16 as 2 to some power? Can I write 16 2 to some power? And the answer is yes. 16, you can write it 2 to the power 4. 2 to the power 4. So 2 to the power 3x minus 8 would be equal to 2 to the power 4. So now we have the same base, which is 2 here and 2 here. Okay, good. Now using this fact, then m equals n. So 3x minus 8 is equal to 4. Now you have m equals n. Now you have first degree equation. You solve it. You add 8 to both sides, and then you divide both sides by 3, and you get the solution. So the solution set is 4. If you substitute 4 now into the original equation, you will get 16 equals 16. If you replace x by 4, so it would be 12 minus 8, 4, 2 to the power 4, 16, 16 equals 16. So 4 makes this equation a true statement. So 4 is the solution of part A of the question in A. Now, if you want to understand this graphically, in fact, you have two functions here. You have an exponential function, which is y1 equals to 2 to the power 3x minus 8. And you have y equals to 16, which is a horizontal line. So this line is the graph, the red line is the graph of y equals 16. And this curve is the graph of 2 to the power 3x minus 8. We need them to be equal. It means you are searching for this point, which is the intersection point. This is the intersection point between the two curves. If you go down, you will find that x is 4. So the answer would be x equals to 4. Okay, let us solve the second question. 27 to the power x plus 3 equals 9 to the power x minus 1. Well, the idea, express both sides in terms of the same base. What is the same base you can find here? 3. Why 3? Because 9 is a 3 square and 27 is 3 cube. So you can replace 27 by 3 cube, replace 9 by 3 square, and now you have a formula that says if a power is raised to a power, you multiply the exponents. Yani if you have a to the power m all to the power n, this would be a to the power m times n. You multiply 3 times x plus 3, 2 times x minus 1. Now m should be equal to n. Since you have the same base now, so the powers are equal. So 3 times x plus 3 is equal to 2 times x minus 1. Now you have a linear equation. This is 0, 0, 1. Multiply, expand, take x to one side, the variable to one side, and the numbers to the other side, subtract 2x, and then subtract 9, and then you get the answer x equals negative 11. Now, if you substitute negative 11 in the original question here, negative 11 plus 3, it would be 27 to the power 8. And negative 11 minus 1, it would be 9 to the power negative 12. So you will have this one. And if you use the calculator, you will find these two are exactly equal. So the solution set is negative 11. Let us solve some questions. Here the base is 5. 125 is 5 to the power 3. You can check by the calculator that 5 times 5 times 5 is 125. So 3x minus 6 would be equal to 3, and we add 3 to both sides. 3 plus 6 would be 9, and we divide by 3, so x would be 3. You can check your answer, and you will find that 3 is the solution of this equation. Here I have 8 and 4. The base which we can find is 2, because 8 is 2 to the power 3, and 4 is 2 to the power 2. Now you multiply 3 times x plus 2, and here 2 times x minus 3. And now the bases are equal, so the powers are equal. So 3x plus 6 equals to 2x minus 6. I subtract 2x from both sides, and I add negative 6 to both sides. Then x would be negative 12. Another, please try this by yourself, okay? You can write 64 4 times something. You can write both here to the power 2, to the base 2, make the same base 2, and check that you get the same answer. Some more questions from the book. These are the examples required from us. Write 32 in terms of 2 and solve the question. Let me solve 13 here. I have the base 3. The base in the left-hand side is 3. So the base in the right hand side should be also 3. In fact, 27 is 3 to the power 3, and I can write it 3 to the power 3. And then you can take it up. 1 over 27 would be 3 to the power negative 3. And now the bases are the same, so the powers would be the same, and you solve the equation. If you solve the equation, you will find that x is 4. What about this one? Here, square root of 6 is actually 6 to the power half. So x minus 3 over 4 would be equal to half. If you cross multiply, so you have 2 times x minus 3 equals 1 times 4, which is 4. And now you expand 2x minus 6 equals 4. If you take x to the other side, you get 10. And if you divide by 2, you get 5. So the answer is 5. You can do number 19. Write both sides in terms of base 2. Okay, so this is objective 1. This is the first method. Now let us go to objective 2, the second method. It is not always possible to write both sides with the same base. Look here, for example, 4 to the power x equals 15. We cannot rewrite both sides in terms of base 2 or 4. You cannot write 15, 4 to some power or 2 to some power. So the method in objective 1 is not always possible. So what can we do? If we can't write both sides with the same base, what can we do? We use logarithms to solve the exponential equations. How do we do that? We follow these steps. You have to memorize and understand these steps. How to use logarithms to solve exponential equations first. And this is very important. Isolate the exponential expression. Means 4 to the power x has to be alone in one side. Okay, isolate. So this example is okay. It is isolated. The exponential expression is isolated. Here, the exponential expression is also isolated. That's good. And also here and here, it is isolated. But here, it is not isolated. The exponential expression is e to the power 0.6 times x. This 40 has to be removed, and this negative 3 has to be removed from here. So we should have e to the power 0.6x alone in one side. So this is what we mean by isolate the exponential expression or the exponential factor. You cannot solve this equation unless you first isolate the exponential expression. The second method, you take the log on both sides. You apply the common logarithm or the natural logarithm to both sides. If the base is 10, use the common logarithm. If the base is not 10, it is easier to use the natural logarithm. So take the log of both sides. How? Here, look to the first question. The exponential expression 4 to the power x is already isolated on the left-hand side, alhamdulillah. So we don't have to do anything with it. So we go to the next step. We take the natural logarithm because the base is 4, it's not 10. The natural logarithm on both sides. So we have ln 4 to the power x equals ln 15. This is what we mean by taking the natural logarithm on both sides. Okay, why we do that? Because we can use the power rule to bring the x outside. So ln 4 to the power x would be written as x times ln 4. And then we divide by ln 4 and solve the equation for x, and this would be the answer. So the answer is ln 15 over ln 4. So we take the log of both sides, then we simplify using one of the following properties. Okay, you will use the power rule. This is the power rule, bring x here, or if it is len ex, they cancel each other and you have x, or if it is log 10 to the power x, log and 10 cancels each other because the base here is 10 and you get x. You will get one of these three. You will use one of these three and then you solve for the variable. Okay, let us solve another question. This one, for example, the base here is 10 and the exponential expression is already isolated. Okay, so I take log of both sides because the base is 10. Because log 10x, they cancel each other and I immediately get x. So x would be log 1,000, 120 thousandths. Okay, this would be the answer. طبعا if you want to find an approximation of the answer, you can use the calculator to get log 1,000, 120 thousandths by calculator. You will get 5.08. Let us solve these exercises. Immediately I will use len. So len 5x equals len 134, because I cannot write 134 as 5 to some power. I cannot make the bases the same here. Now I take x using the power rule. So x len 5 would be equal to len 134, and then x would be len 134 over len 5, and that's the answer. I can approximate the answer using the calculator. Here I use log because this is 10 to the power x, the base is 10. So 8,000, log cancels 10 and x would be equal to log 8,000. That's the answer. Now let us try another example where the exponential expression or factor is not isolated like here. Now here we begin by adding 3 to both sides to get rid of this 3. So if you add 3 to both sides, you have 237 plus 3, 240. Okay, good. Now you have 40 here. You have to get rid of this 40. So we divide by 40. We divide both sides by 40. We get e to the power 0.6, x equals 6. Now we are ready to apply len to both sides. Remember, len ex equals x. They cancel each other. So 0.6x would be len 6 and x would be len 6 over 0.6. That's the answer. So here, for example, we begin by taking 5 to the other side. So 58 plus 5 would be 63. And then we divide both sides by 7. And then we apply len. If you don't follow these steps, your answer will not be correct. And then len and e cancels each other, and we have 2x equals len 63 over 7, and the final answer would be x equals len 63 over 7 over 2. He said, use a calculator to obtain a decimal approximation to 2 decimal places. Okay, I will use the calculator. I will put len 63 divided by 7 equals, the answer is 2 point something, divide by 2, the answer is 1.09861 and so on. He said 2 decimal places. 2 decimal places, yani 2 numbers after the decimal. So I need 0, 9. Now I look to this number after 9, 8. It's greater than 5. So I have to add 1 to 9. So if you add 1 to 9, it would be 10. So I have 1.10. So this is the final answer. Here, please try this one by yourself and make sure that you get this answer approximated to 2 decimal places, and here also the answer approximated to 2 decimal places. I think this is, yeah, this is exactly this one, but it's okay. This is a third example. Please check, apply len to both sides, and make sure that the answer is 1.09. Another example today, maybe it is the last one. Now we have, look carefully to this example. We have two exponential expressions. We have e to the power x, and we have e to the power 2x. Okay, so this is really not easy. It is difficult than the previous examples. So what should we do? We use a quadratic in form. Do you remember in 001 we studied the quadratic in form equations? These are the equations that can be transformed to quadratic equations by some substitution. The substitution here is this one. You take u equals e to the power x. If you take u equals to e to the power x and square both sides, then u square would be e to the power x to the power 2, and we said we multiply the powers, so it would be 2x. So e to the power 2x would be u square minus 4 e to the power x would be u plus 3 equals to 0. And now we have a quadratic equation. This is a quadratic equation. We can solve it by factoring. So factor u minus, he went back to e. I can do it like this, and u minus 3 times u minus 1, and then either u is 3 or u is 1, and then u is e to the power x. So you write e to the power x equals to 3 or e to the power x equals to 1. Okay, or you can just factor immediately like here, and you will get the same answer. E to the power x equals 3 and e to the power x equals 1. And what should you do now? You have two equations now. I have two equations. So it is using objective 1, I apply len to both sides. Len to both sides, I get x equals len 3, x equals to len 1, and len 1 is 0. So I have two solutions, 0 and len 3. Okay, so there are two solutions, 0 and len 3. This is the solution of this equation. Let us solve this equation. If you understand that this is ex and this is e to the power 2x, so you can immediately factor. Okay, for e to the power 2x, you can write it e to the power x times e to the power x. And plus 7, search for two numbers, their product is plus 7, and their sum is negative 8. So this is minus 7 and minus 1. Now you will have either ex equals to 7 or ex equals 1. And now you apply len to both sides, so you get x equals len 7 or x equals len 1, which is 0. So there are two solutions. These are again some exercises from the book about the same objective. Here you apply log immediately. Here you have to divide by 3 first and then apply len. Here you have to take 2 to the other side and then apply len. Here you apply len immediately. Okay, and this is, let us solve this 145. You have e to the power 2x here and e to the power 4x here. If you call this u, this would be u square. In fact, you can factor this immediately, and this is a quadratic in form. E to the power 4x can be written as e to the power 2x times e to the power 2x. This will give you, the product will give you e to the power 4x. And then negative 24. I need two numbers. Their product is negative 24. Their sum is 5. So it's plus 8 and minus 3. Now I will have two equations. E to the power 2x equals negative 8. And this equation is impossible. because the exponential function cannot be negative, as we have seen in section 4.1. The second equation would be e to the power 2x equals 3. We apply ln to both sides, so 2x would be equal to ln 3, and then we divide by 2, so x is ln 3 over 2. That's the only solution of this equation. I leave 47 for you. You factor immediately and you solve it. The only difference, the base here is 3, not e. I stop here. We finished objectives 1 and 2. And if you have any question, feel free to ask.